Hello, everyone. Thank you for dialing in. I think we still have a few participants joining, so maybe give them a chance to tune in and we'll start in 1 or 2 minutes. Thank you. All right, let's get started. Dear participants, good morning, good afternoon, good evening. Great to see so many familiar names in this webinar, also a few that I do not know yet. So for those, my name is Jens Jäger. I'm the Director of Policy and Business Development, ARE. Have the pleasure of giving a few opening remarks. I'll keep it brief to allow max time for the actual content. So yeah, we're here for the second webinar in the Innovation for Education series of 2025. As some of you may know, we created this showcase webinar series to bring our members one step closer to potential collaborators, giving the opportunity to showcase products and solutions, especially innovative ones. As many of you may have seen, we also launched a parallel newsletter on the same topic yesterday. So feel free to check out the ARE website or your inbox to read the detailed articles with contributions from a number of ARE members. So the topic of today is renewable energy generation technologies, which have grown rapidly in the past years, triggered by technological innovation, also in some countries conducive policy support. And so that has led to favorable cost reductions and efficiency improvements, especially on solar PV and wind. But today you will also hear about a number of other cutting-edge renewable energy technologies such as hydro, ocean, bioenergy, airborne wind, green hydrogen, etc. All of those can be part of the solution for edification, depending on the context. The increased adaptation of renewables is, of course, accelerating the overall decarbonization of economies and also helping with the mission of transitioning from fossil fuels and improving electricity access. ARE members are at the forefront of this innovation, and so we've invited some of our industry expert and thought leaders today for this webinar to present some of the state-of-the-art solutions we have in the market. We have 6 members here in this edition of the I4E series webinars to explain projects and solutions, and my colleague Carlos will moderate and introduce them in a moment, moderate the debate. So before anyone asks about those presentations you'll see, please note that the session will be recorded and be made available afterwards on the ARE website. You can also ask questions on an ongoing basis in the chat, and then we will address them to the extent possible in the Q&A part of the webinar. For those of you that do not know ARE and what we are and what we stand for, essentially ARE, we're the Global Business Association for Distributed Renewables. We represent about 200 members worldwide along the value chain, so from investors to developers to technology providers and manufacturers. And IRE works to expand sustainable electricity access, and with that also create jobs and respond to climate change in Africa, Asia Pacific, and Latin America and the Caribbean. We are active globally. So this map illustrates we have members that work all over the globe, as said, primarily in Africa, Asia, and Latin America, with the biggest hubs in Africa. And we are renewable energy technology agnostic, meaning that our members can work on any type of renewable energy technology and even also the accompanying components. In terms of system sizes, we also promote any type of system size that fits the context, the local context. So that can be standalone systems, such as solar home systems, or in others, mini grids, or even grid solutions powered by renewables. As our mission overall is supporting private sector driven markets, we provide services to companies and entities that are members of the Alliance. These include business and market development support, capacity building, policy and advocacy, as well as communication and marketing services. Of course, if you are interested in receiving such services and you're not yet a member, you can contact me or any part of the IRE team and we can discuss that more in detail. So with that, I will hand it over to Carlos for the moderation and facilitation of the presentations. Wish everyone a great and insightful webinar, and see you soon. Over to you, Carlos. Thank you.
Thank you very much, Jens, for the introduction, and good morning, good evening, good afternoon to everyone, to all the attendees joining from all over the world. My name is Carlos. I'm Business Development Assistant at IRE, and from this point onwards, I will have the great pleasure of being the facilitator of this webinar. As mentioned by my colleague Jens, second of the year, today on the topic renewable energy generation technologies. And for that, we'll have a great panel of experts of the IRE community who will be showcasing their innovations, their projects, and their solutions on this matter. Given that Jens has already given you the background about the webinar, as well as the background about IRE, the organization behind it, now I'll be happy to start with the presentations. However, before that, a couple of remarks. The first one is for the speakers. Dear speakers, please try to comply as much as possible with the time, meaning you will have 8 minutes for doing your presentations. Being mindful of the time, please try to comply with this so we have enough time at the end for the Q&A session. Talking about that, dear audience, please make sure you ask your questions by using the Q&A feature of GoToWebinar. There's a question box right in the GoToWebinar platform that you can use in order to ask your questions. And after the presentations, we'll have a short Q&A session where I'll be redirecting the questions to the speakers. And also, please try to specify who are you asking the question to. Having said that, now happy to introduce the first speaker of the day, who is Charlotte Pendry, who is representing Electriciens Sans Frontières, and she's Emergency Project Manager. Hi, Charlotte, it's a pleasure to have you here. And for the next 8 minutes, the floor is all yours. So thank you very much.
Thank you very much for the presentation. So hello everyone, and thank you for the opportunity to speak today. So in this presentation, I'll introduce Electriciens Sans Frontières. Maybe can you pass the first slide? Electriciens Sans Frontières is a French NGO working in the field of energy solidarity, and more specifically, I'll focus on our operations in Ukraine, since the beginning of the war with the deployment of hybrid energy solutions. This is a technological innovation designed to meet urgent needs while paving the way toward long-term decentralized energy systems. Next slide, please. So Electriciens Sans Frontières was created in 1986 and fights against inequalities in access to electricity and water across the world. Our approach relies on the expertise of 1,200 volunteers, mainly professionals from the energy and water sectors, and on partnerships with local actors. Our action is represented by the implementation of 120 projects in nearly 40 countries, always with a focus on sustainability and renewable energy. Next slide, please. Our work falls into three main categories. First, development projects, which is about 70% of our work, focusing on energy access to improve health, education, and the economic development in underserved communities. Second, emergency and post-emergency interventions that aim to provide rapid, efficient, and long-lasting support in crisis-affected areas. And third, technical expertise project, where we support other NGOs and humanitarian actors by helping them integrate reliable energy and water systems into their intervention. Next slide, please. Our projects in Ukraine fall into the second category and perfectly illustrate the importance of energy access in emergency contexts. To give you some context, before the war, Ukraine's energy system was connected to Russia and operated through a centralized model. The total installed capacity was about 55 gigawatts, with coal representing 22 gigawatts, nuclear 13.8 gigawatts, and solar only 1.9 gigawatts. This energy was mainly produced through large centralized power plants, like in Zaporizhzhia or Dnipro, as you can see at the bottom of the slide. Since February 2022, Ukraine has disconnected from Russia's grid and synchronized with the European one. At the same time, the country has endured over 2 years of intense attacks, mainly targeting its energy infrastructures. One of the worst days was March 22 in 2024, when a massive coordinated strike that damaged energy facilities in over 10 regions in Ukraine. As a result, nuclear production specifically has dropped sharply, leading to widespread instability and insecurity for millions of Ukrainians, as you can see also at the bottom right of the slide. Next slide, please. So on this map, you can see the most critical energy infrastructures that have been damaged, destroyed, or occupied by Russian forces since February 2022. The centralized system that powered Ukraine pre-war is no longer functional at national scale. This crisis highlights a key vulnerability, the over-reliance on large centralized power plants. It has underscored the urgent need for decentralized energy solutions that can function independently of the national grid. Next slide, please. This energy instability has very concrete effects on people's life. It limits access to safe drinking water, interrupts education, affects access to healthcare, and creates significant insecurity, especially at night, due to lack of lighting. These are essential services that cannot function without stable electricity. As you can see, there's a main difference since before and after the war. Next slide, please. In response to this, Electriciens Sans Frontières launched an initial emergency project in 2022 with the support of the French Ministry of Foreign Affairs through its Crisis and Support Center. The aim was to send in essential energy equipment to communities across Ukraine, and over 170 tons of equipment, including generators, heaters, solar lamps, were delivered, reaching close to 2 million people. But as the situation worsened in 2023 and 2024, with increasing attacks and longer power cuts, we realized the limitations of sending diesel generator. Their lifespan is short, fuel supply is uncertain and expensive, and they are not a sustainable solution. Next slide, please. As such, in September 2023, after a field-based assessment of energy needs, we launched a new project, Hybrid Solutions. The project reflects a major shift in approach from short-term reactive support to longer-term resilient solutions. At the heart of the project is the concept of decentralized hybrid systems, installations that combine solar panels, battery storage, and a diesel generator for backup. The solar panels provide electricity during the day, the batteries store power for later use, and the generator acts as a last resort in case of extended blackouts. The goal is to ensure energy autonomy even during prolonged blackouts while minimizing reliance on fossil fuels. Thanks to support from the French Ministry of Foreign Affairs and our Ukrainian partners, Fortechny Foundation, Kamzel, and EnerKite for Ukraine, we have been able to install this system in nearly 100 public infrastructures, including schools, shelters, hospitals, health centers, and pumping stations across 10 regions in Ukraine. And you can see an example of a pumping station at the bottom of the slide. By providing them really reliable, low-emission energy systems, we help ensure continuity of essential services, especially in areas that face frequent power outage lasting up to 8 hours a day. Next slide, please. I'm not sure. This shift to decentralized hybrid system is more than just technical. In a country where centralized infrastructure is constantly under attack, resilience depends on decentralizations. These systems are also designed to be replicable. We've developed technical documentation, trained local technicians, and are building long-term maintenance capacity so the systems last well beyond our presence. We also collaborate closely with both French and Ukrainian municipalities to ensure an effective deployment. I recently attended the 3rd International Summit of Cities and Regions in Kyiv to reinforce these partnerships. We are also approached by French companies wishing to contribute, and thanks to our in-depth knowledge of the energy landscape and our trusted relationship with both public and private actors, we are in a unique position to coordinate meaningful actions. Next slide. To conclude, hybrid energy solutions are a powerful tool to ensure access to essential services, even in the context of war. They offer a path toward greater resilience, autonomy, and sustainability for affected populations. Thank you very much for your attention.
Thank you very much, Charlotte, for the impressive presentation. It's really great to see everything that Electriciens and Frontières is doing in order to manage this crisis. It's a very interesting presentation, and thank you very much for that. Dear audience, please make sure you are asking your questions using the Q&A feature of GoToWebinar, so Charlotte can answer them at the end of the webinar today. Now we will move to the second presentation that is going to be provided by Mr. Florian Breipohl, who is the CEO of EnerKite. Hi, Florian. Nice to see you. I'm especially interested in knowing more about your airborne technologies, which, to be honest, I find fascinating. So, Florian, thank you very much, and the floor is yours for the next 8 minutes. Thank you.
Thank you very much. Can I be heard? Is audio okay?
Yes, we can hear you.
Perfect. Okay, then next slide, please. Yeah, thank you very much for the opportunity to present EnerKite Airborne Wind Energy. We are also a very decentralized system that can offer baseload power very near to the customer by using kites. Next slide, please. We are addressing two major problems in the field of independency and resilience. The one problem is that in a majority of countries, we can see a high fluctuation of energy prices, which is threatening companies that have a high power and a high and constant power demand. So these fluctuations on the energy market are threatening their businesses and bringing a lot of uncertainty into long-term planning. Next slide, please. The other problem is that in emerging countries, or of course also in Ukraine, as mentioned, we can see a certain amount of power outages due to weak grid connections. And here we can see a World Bank study that was dealing with the costs of power outages for these companies and also for the regions. And we can see that we have a cost of 140 billion euros per year for these companies, and this affects a GDP of 28% in average for these kind of countries. So fluctuations of energy prices and a weak grid combined poses a lot of threat in basically globally, we can say, even in Europe. Next slide, please. So these companies, it's farming, it's production companies that are looking for an alternative to the grid connection. And the traditional renewables are not able to cater this demand very, very good, because if you look at wind, small wind turbines nearby the customer are often not very efficient and doesn't bring this continuous power supply throughout the whole year. And large wind turbines are often quite too large, and they need, of course, a good infrastructure, a good grid, and logistics. So that's not really a fit. Photovoltaics with battery storage is working really good in some regions, but also if you want to cater a company that has a high power demand and a very constant power demand day and night in 3 shifts throughout the whole year, in most of the countries, you would need a lot of space and storage to be able to cater the constant demand. And of course, diesel generators are not an option anymore in the near future. So that's not an option. So that's where airborne wind energy systems are coming in. We use kites to operate in very high altitudes, starting from 200 meters up to 300-400 meters. And we need, therefore, a very small amount of material, and we are very compact systems that can be placed very near to the customer. So with these kind of systems, we can reach with a small amount of material a very constant power supply for these kind of applications. Next slide, please. So how does it work? When you look at the right side, we can see that the system is consisting of 3 main components: the ground station, where the generator is located, also the battery storage system, and all the controls that are needed to control the kite, like a kite surfer. Then we have a 3 tether system for left and right and up and down. And we have the kite, which is basically just a kite. And the system is pumping up and down. And at each pull phase, we produce power on the ground, and then we retract the kite back, and then we pull again. So that's called the pumping system. And the efficiency between pumping or pulling and retraction is 90% to 10% from the time. And EnerKite is able to launch and land the kite in a special way. So the system is able to be launched and landed even when there's no wind at all on the ground. And a small breeze of 3 to 4 meters per second is sufficient to start power production, which is very likely to find in high altitudes. So that's why we are very constant in the power production. Next slide, please. Yeah, here you can see the system running. So we have quite some years of development behind us and testing. So the system is functioning fully automated, like in future, like a wind turbine. Now we still have to say start and stop, but the autopilot is controlling the system fully autonomous. And now we are building our first of a kind ground station system with 100 kilowatt nominal power, which will deliver 500 megawatt hours per year roundabout, depending on the local conditions. And on the right, we can see our first of a kind. that is very easily to deploy. So we can bring it into operation in 2 hours and also change the place without leaving anything. We need no foundations, nothing, and we can place it elsewhere. So very quick deployment. Next slide, please. So that will be the system, the product at the end. Of course, it will be not so quickly to deploy and to install because the project lifetime is 20 years. So that means we can deliver 20 years of power safety and a constant price for the power for 20 years. So we can make the companies independent from the local energy market. Next slide, please. So in the combination between a compact system and a low wind design brings us to the point that we can triple the landmass suitable for wind energy, which we can see on the right top. So 80% of the landmass is then suitable for wind energy production. So we can reach nearer to the equator and reach more countries that are not suitable for traditional wind turbines, either not viable economically or from the logistics and transport not feasible. Next slide, please. So here we can see how the system is producing power. So we can see here on the top the constant power delivered by an EnerKite at the same location in black. We can see the wind turbines, so less constant, and of course PV. This is a location in Germany, of course. So we can see we can deliver baseload power. And when we look at the prices for electricity in Germany and Europe, we see that EnerKites are able to produce power at a cost much lower than the electricity price. And that is, of course, also the case in regions where you need diesel generators and diesel power supply. Thank you. Next slide, please. Yeah, and of course, if you replace diesel, we can save a lot of diesel. So we are at 4.4 million liters of diesel over the lifetime of only one EnerKite system. So that, of course, bears a lot of logistics again, a lot of storage facilities and all this. So we can get rid of all that, and of course of CO2. Next slide, please. Yeah, the main applications for our system are e-mobility, so a decentralized autonomous self-charging infrastructure, fast charging infrastructure. So we can bring e-mobility everywhere. Of course, the self-supply, so for farming and production, but also microgrids, so a combination between PV, wind turbines, and biogas, for example. There we can be implemented as a system that stabilizes the grid for local grids. Next slide, please. Yeah, the aim, of course, our big vision is that we are able to replace all the diesel generators in all the locations that are shown here. This is a study from the Rainer Lemoine Institute from 2013, and these kind of the red dots on the map are all diesel catered local grids, and these microgrids will tenfold in the next decade. So we have to find another solution than diesel generators, and we have to replace the existing diesel generators with other systems, and that's where EnerKite comes into place, and we want to produce a lot of them to cater this demand. Next slide, please. Yeah. So I'm happy to welcome everybody who wants to join this vision and to help us to get rid of big polluting diesel generators at the end. And bring energy to remote locations. And thank you very much.
Fantastic. Thanks, Florian. Thanks a lot. It's been super interesting. I find marvelous to hear about these kites and airborne technologies. I'm really looking forward to having you participating in even more speaking opportunities. So thank you very much. Please, dear audience, I'm sure that you have many questions for Florian, so I would invite you to ask them, and I will redirect them in the end. So now it's time for moving to the third speaker of the day, who is actually Mr. Kumaresh, who is the Deputy Head of Engineering at Grips Energy. Hi, Rahul.
Hello.
Thank you very much. Yeah, so I'm really looking forward to hearing from Grips' work. So yeah, floor is yours.
Yes. So good day to the world. This is Rahul Kumaresh from Grips Energy. What I do is I'm the Deputy Head of Engineering and the Program Manager for the company. What we do as a company is we are a project financier and a project developer based out of Berlin, Germany, and all our projects are predominantly in sub-Saharan Africa. We work with our EPC partners to construct, commission, and operate the projects. We own, lease, and operate the projects throughout the lease period. So that's a short introduction of the company. We can start with the slides. Yes, we can. Yeah, what I would be talking about is overcoming operational challenges in PV plus ESS for C&I projects in Zambia. This would be a little technical, but I will keep it as high level as possible so the audience around the world could understand it better. Next slide. So this is a case study of one of my favorite projects, which I implemented with my colleagues. So we have a 374 kilowatt peak of PV generation capacity, 800 kilowatt hours of battery system with online UPS functionality. The project is about 10 years lease. It's on a 10-year lease. We commissioned the project on 2022. And we installed the project through our local EPC partner in Zambia. So the customer is the leading meat processor in Zambia and supplies nationwide. So they are important for the country's welfare, well-being, and industrial needs. What we do, how we help the customer is our solution helps the customer to reduce about 20 to 30% of electricity usage and also reduce their carbon footprint finally. Next slide. Okay, this is an overview or a helicopter view of the project. If you look at the yellow section, that's where it started. We started constructing the project in 2021. We initially commissioned 250 kilowatt peak of PV, 500 kilowatt PCS power conversion system or an online UPS, and an 800 kilowatt hour battery. After 2 years, the customer liked us even more. They asked for an extra top-up, which is 125 kilowatt peak of PV. Then they liked us even more. We installed another 230 kilowatt peak, or that project is currently going as we speak. So those are the areas where it's marked. Those are the locations where the PV is installed, and there's a separate power room around the area there where the battery system is installed. You can go to the next slide. Okay, just to list a list of major components. The PV modules are Jinko Solar, again state-of-the-art manufacturer. Inverters and inverters are from Artis from China. Also, currently, as of today, a leading manufacturer. The battery system is from South Africa called Freedom One, and the remote monitoring system is from a company called Breipohl Energy out of Germany. Next slide, please. So I'll go through the initial challenges of the projects. Again, the whole purpose of this presentation is to give you lessons learned of what we went through. So it's important for our partners and customers who are moving into renewable energy technologies to look forward to. So what we understood is a factory acceptance test and a pre-site inspection is not enough. We need to always ensure that the product is made for the region and for the country, because the grids are different and the environmental conditions are different from country to country. So please ensure that the product is suitable for your region and tested well. Language barriers, we had a challenge. Whenever we had a challenge, we weren't able to speak to the technicians or the head of engineering at inverter side or the inverter supplier, because they are from Shenzhen in China, so they could not speak a word in English. So this was challenging. How we solved this is we did use a Chinese translator, but this went on for over a year. And people may ask, why didn't you choose better options or more state-of-the-art options? The reason being, at that point in 2021, when the project came through, there were limited options in the market. Also, one of the reasons, at the end of the day, what comes to play is the cost. So we find the best solution available with keeping in mind the budget parameters. Another challenge we noticed is knowledge gaps with the EPCs in sub-Saharan Africa, where the understanding of complex electrical, electronics, and software is sparse. So then we had to use our engineering team from Germany, from headquarters, and support and train them for them to be able to troubleshoot the system. We also noticed construction management and health and safety practices were not of global standard. So we installed regular monitoring and control systems in place in our project management approach, and also during our operations to ensure no incidents happen or the highest quality project is being delivered. Another gap we noticed is the principal contractor versus the EPC. The expectations of the project financier or a developer versus the construction company, the gap is massive of what the final product or the final system should be. So we have regular meetings and training sessions and collaborative sessions with the EPCs to ensure that they are able to manage our expectations. Let's go to the next slide. So this slide will be a little more on the technical side, but let's go. So Zambia, as we all know, is one of the countries in sub-Saharan Africa which faces a lot of grid instability and load shedding. We're looking at about 10 to 15 hours a day. So thereby a system like ours is very, very important and must be resilient to changeovers. So I'm going to explain you two short scenarios when the switching happens between the grid to the battery system and from the battery system to the diesel generator. So as you know, the client has a series production line, which is fully automated. So when the switching happens between the grid and the battery system, we realize that there are a lot of inrush currents which are being developed from all the larger and smaller motors from the factory, and this puts the inverter in. It crashes the inverter. That means it shuts down the whole facility. We also realized that the battery management system has a protective mechanism that would trigger any inrush. If it notices any inrush currents, it would turn off the battery. So both the inverter turns off or the battery turns off. We also realized that the communication system cannot handle any sensitive changes. So these three other learnings. We also realized that the manufacturer's operation manual is not complete when we install the system. So thereby the system we were the benchmark system in sub-Saharan Africa, and our system was used to develop their operation manual. So how we solved this? We took over about 8 to 9 months to solve these problems because the customer were not able to use the system efficiently. So as phase one, as immediate actions, we recommended the customer to have sequential startup of motors. That means starting up the larger motors and then starting up the smaller motors. We decreased the sensitivity of the system by increasing the range of the protection parameters. That's we're talking about voltage, frequency, and phase. Then we did some load side modifications where all the motors which were above 35 kilowatt, there were VSDs installed, and motors which are below 35 kilowatt, soft starters were installed. We also recommended the customer to install a dedicated power factor correction system, which also solved all the problems. As phase three, which would require higher capex, which was still not implemented, but it is a recommendation to the customer, is that they could install another power conversion system and also increase the size of the battery with a higher C rating to avoid the crashing problem. The next below is the diesel generator. So while switching from the battery system to the diesel generator, again there was a lot of crashing involved. We understood that the diesel with the diesel generator was not synced with the inverter. The diesel was not able to accept the full loads, and the system configurations were incorrect. There was a lot of frequency drop and voltage slags. What we did is we divided the critical and non-critical loads. We recommended the customer to install a load management system, and we modified the firmware of the inverter to ramp up and ramp down the diesel generator, allowing for seamless transition. Last slide. We need to go to the last slide. Yes. So finally, the key takeaways from our project is ensure that every project is given its due importance, and every customer is given, every project is catered to every customer, so that you do not face problems as what I explained earlier. Ensure you have a proper relationship with your EPCs or your partner, and you work collaboratively so that you solve problems together. And ultimately, data is key. Ensure you collect live operating data with your remote monitoring system. Doesn't matter what renewable energy technology you're using, so that you can solve problems. It's only if you see, you can solve. Thank you. Last slide. And have a good day.
Thank you. Thank you very much, Rahul, for the presentation, and thank you for guiding us through all the challenges that you had to face for this project in Zambia, and also for all the solutions. I'm sure that's going to be really useful for a lot of project developers who are in the audience right now. So thank you very much for that. Now we'll move to the fourth speaker of the day, who is Mr. Jeff Lee, representing INGINE Wave Energy Systems. He's the managing director. Hi, Jeff. Nice to see you. And Jeff is going to guide us through their innovative wave technology. We're looking forward to hear what they do. So thanks, Jeff, and the floor is yours for the next 8 minutes. Thank you.
Thank you, Carlos. Thank you, ARE. Thank you, everyone. Thank you for having me. My name is Jeff Lee. I'm talking about ocean wave energy. So we heard about the solar, wind. Now we are talking about next generation energy resource. Next, please. So I'm talking today about case study of microgrid integration using wave energy solution. Next, please. Our approach is quite unique to think about how to assist remote islands resident. There are 700 million people living in islands in all of the world. 400 million still relies on diesel generator. They do have problem of the limited access of the grid. They are isolated. On the other hand, look at the ocean. Look at the ocean. It is surrounded by rich ocean wave resource, which is dense, consistent, and predictable. Then we are talking about how to commercialize this new energy generation. Next, please. So this is easy to understand, typical daily chart. It is complementary because a big chart in the daytime, the solar energy you can see dominantly, but at night it is not operating. Also in the monsoon season or unexpected season, wind energy is not very consistent. So in the meantime, wave energy, as you can see, relatively smoother and much less intermittent, which is very much complementary factor of the microgrid. Okay, next. When you see the map, the red colored ink and yellow color is obviously very strong waves place. That's why we are in the UK and Scotland. And when you see smaller waves, which is blue color ink, but still 10 kilowatt per meter, we can harvest the wave energy in the nearshore. So that is why we are in the Indian Ocean, for example, 22% of the whole market potential. So it is actually estimated by the Ocean Energy System, year 2023, the potential market of the wave energy is more than 300 gigawatt capacity. Okay, thank you. Next please. So when it comes to the ocean wave energy, most of the companies go to the offshore deep water because they have to generate the utility scale in the first place. But they are facing harsh and extreme weather condition, obviously, and also a huge cost. For example, subsea cabling system is $3 million per kilometer, which is also apart from extra repairing cost, another $3 million per kilometer. But on the other hand, we are locating in the remote island in the shoreline and the near shore. So our solution do not require any subsea electric cables at all. And it is easy to install and easy to maintain. And this technology is actually fully protected together with the 63 patents all over the world. And we became top tier technology announced by the European Patent Office. Okay, next slide. Recent 3 years, we are active in Southeast Asia. Thanks to the grant, significant grant in 2 times from Innovate UK, last 3 years, we secured our position to develop pilot project in Indonesia. So by end of this year, we're gonna install 125 kilowatt capacity as a demonstration. Thus, this demonstration is commercialized demonstration. So right after this, we will scale up to 1.5 megawatt capacity. Then we can definitely compete against the diesel generator, which is expensive and polluted. So 2-3 years time, and this year is very significant, very important to get extra demonstration. So we are still expecting 1 million British pound to match this installation. Thank you. Next page. So now I'm talking about the case study. We have found a small island in Vietnam. There are existing small solar PV and 2 small sets of the diesel gen together with a not very active storage system. So we include estimated and calculated together with our wave energy system to call it hybrid microgrid system together with the solar, wave, and storage. Okay, next page, please. Next page, please. Yes. So this graph on the left-hand side, it is existing solar PV only on the small island. And the right-hand side, it is together with the wave energy. Okay, let's look at the left-hand side first. Obviously, y-axis is the power load. The positive number is over demand and negative numbers are over supply. And the daily chart and 6 different colors, meaning 6 different months, the average numbers. So when you see this graph, you will see definitely diesel generator is still required because the solar PV is only helpful during the sunny day in the specific winter time when the power demand is much lower. But on the other hand, there are huge power demand and they cannot meet. So they still require diesel generator. The full renewable energy hour is only possible during the sunny hours. On the right-hand side, as you can see, together with the wave energy combined, diesel generator is actually can be fully phased out during the winter months. When you see the blue colors and significant oversupply, it's well balanced together with the wave energy in the strong waves. But in the summertime, still there is a bit of challenge to overcome the over demand, but we can definitely consider extra storage system at night, and this can be surely managed. Next slide, please. Simply speaking, the diesel generator to be phased out. That means significantly reduced of the CO2 also emission, reducing the fuel cost, because of diesel generator is very expensive. So we are saving a lot of money. And at the same time, through our oversupply, we can increase the fresh water, which is the desalination plant. And also we are helping agricultural, aquaculture activities in the local remote islands. So for example, we provide extra power to generate a coffee bean. So we can say wave energy driven coffee bean. So it is actually a very practical way of helping remote islands. Okay, next slide. So this is final slide. I'm trying to say hybrid microgrid together with the wave energy. It can be much more cost-effective, sustainable energy in the remote islands, in coastal communities. So we are actively looking for partners, strategic partners, to do the microgrid together with the wave energy. And also we are expecting 1 million British pound extra funding in this stage. So after this event, please feel free to contact me on the bottom. Okay, thank you so much. Thank you.
Thank you, Jeff. Thank you very much. It's super interesting, your technology, and I'm really excited to see it very soon all over the world. Whoever who wants to partner with INGINE, please let us know through the chat, and I will share the contact information with Jeff at the end of the webinar. So yeah, thank you very much, Jeff, for the presentation. And now we will continue with the next speaker of the day, representing JLA Hydro. Hi, Richard. It's very nice to have you here. Also a company from Belgium, where IRE is also based, and that is definitely lovely. So thank you very much, Richard, for being here, and the floor is yours for the next minutes. Thank you.
Thank you, Carlos. Good afternoon, everybody. Just waiting for the presentation. Next slide. Next slide, please, Carlos. Yes, so as you mentioned, we are based in Belgium. We are a company manufacturing hydraulic turbines for small hydropower plants. We've been in the business for 40 years, and we have realized about 140 projects worldwide. That's across 4 different continents. Our solutions are very well adapted to rural electrifications and mini-grids. So we have installed about 30 mini-grids in Africa, from 20 to 800 kilowatts. Next slide, please. So we do manufacture standard turbines such as cross-flow and Pelton turbines. We also offer solutions for smart grid and monitoring solutions. But we have developed as well a project which we call the GLA kit. That's the innovative product I'm going to talk about today. Next slide, please. So the GLA kit, as I said, it's a concept, innovative concept, where the buyer is building his own turbine. So we do provide a kit with all the parts and equipment required, and the buyer will be assembling the turbine by himself. The idea is to reduce the cost as much as possible, to make it affordable to all. So the maximum capacity of the turbine is 20 kilowatt, but it can start from 2 kilowatts. And it can be used for different applications, such as power generation, but as well to run mills or pumps or any other application. We have 3 different standard models. So the standardization is also helping us reduce the cost. Next slide, please. So this is a picture of a kit. So this is how we ship the equipment. As you can see, that's all different parts to be assembled together. And of course, with the kit, we provide a detailed manual. It's a bit a manual like a IKEA manual. Sorry. Next slide. So there is quite a few advantages to the GLA kit. So First of all, it's inspired from our standard turbine, which are proven technology. As I mentioned, we've done many different projects before. Those are quite simple to assemble, thanks to the manual we provide. They're quite reliable. They're quite robust as well. So the shaft line is based on cast iron bearings. The cost is quite low, as I mentioned, the standardization, as well as the fact that the customer is assembling the turbine by himself is reducing the cost. And it's also quite easy to maintain. And of course, as the customer would have assembled it, he would know the turbine by himself quite well, and he would know how to maintain it. Next slide. So that's a picture. On the left, you have a print screen from the manual that we provide, and on the right, you have an actual example of how it's being built. Next. And those pictures are from some projects. So the one on the left is from a site in Burundi. That was a project, a showcase project. On the right, it's a project in Belgium. So this one is actually connected to the grid. But as I mentioned, it can be either connected to the grid or not. And we have done other projects in Rwanda, Madagascar, and so on with the GLA kit. Next slide. One important thing is that the GLA kit, so we can sell it to the customers who would be willing to install a small hydropower plants, but we also used it as a base for knowledge transfer training that we organized in 2016. It was financed by the Dutch development organization, and we organized it in Rwanda, where we did training. We did train about 10 entrepreneurs, and we used it to show them the way to design, conceive, and manufacture cross-flow turbines. So that's it about the GLA kit. Thank you. I'm done, Charles.
Thanks a lot, Richard.
Thank you.
Super interesting. Thank you for bringing to the webinar the hydropower perspective. It's been really interesting. Also impeccable timing. Thank you very much for that. And yeah, whoever is interested in the kit, please let us know, and we will connect you with Richard. And yeah, super interesting. Thank you, Richard. Now we'll move to the last presentation of the day. For that, I have here with me Jawahir. Jawahir, is very nice to see you. Jawahir will be representing Tamarso of Somalia, and also some of the projects that they are working in or work with. So thanks, Jawahir. The floor is yours for the last presentation, and yeah, we look forward to the questions of the audience. Thank you.
Thank you for inviting me, and such a great presentations and a lot of technologies that was represented. So my name is Jawahir. I'm the Chief Operation Officer for Tamarso. I will explain more about Tamarso and our work in the upcoming presentation. So we can go ahead. More we are focusing on, us Tamarso, we're focusing on energizing Somalia into a sustainable future. And that's basically by doing some of DRA solutions, especially mini grids. Can go to the second slide. Tamarso, it's a renewable energy company based in Somalia, headquartered in Somalia, Mogadishu. We were established in 2016 in Mogadishu, and 2024 in Kenya, and now 2025 in Somaliland. We have done over 9 mini grids and 200 CNI projects that's reached up to 5.5 megawatts, and we have up to 45 employees in our companies. So we focus in both aspects, the mini grid and CNI. In the mini grid, we focus more into the rural areas to provide them with electricity. And when it comes to the CNI, we focus on the customers that have a huge consumption, and the electricity is very expensive for them, and they are trying to find a cheaper solution and more sustainable solution. So we provide them with the solar energy. with a backup energy as a batteries or either backup as the generators, but we mostly use batteries as a generator. Next slide, please. So this is our mini grid portfolio. We have done 9 mini grids. The green ones is the mini grids that is operational now, and the red ones, it's our plan up to 2028 to install mini grids in this all red dots, and we are currently working on collecting some international and local investments, grants, whatever it's available that can support us in reaching our goal by 2028 to establish more mini grids, especially and especially all this area, it's urban or pre-urban areas, rural areas that doesn't have any access to electricity, and that will come by me explaining the electricity situation in Somalia in the next slide. So Somalia, we have 50% of the nationality doesn't have access to the electricity, especially in the urban and rural areas. They have zero electricity. Either they have a small generators that runs by private, and that will be turned on like 6 p.m. and then would be turned off by 9 p.m. So they have access to electricity like for 3 hours, and that electricity, it's very, very high. And the second thing, we don't have national grid. That's the thing in Somalia. All the grids that is available, especially in the biggest cities, it's a private grids. So it doesn't have any involvement with the government. It's 100% privately owned. So the price, it can go up and down. It doesn't have a specific price. It depends on the fuel, but that time, since they all operate on the fuel, they used to operate on the fuel, but since 2023, the government has created a plan to, with the World Bank, to energize all the electricity suppliers in the 5 big states in Somalia and supply them with solar energy. And that plan is still not 100% done yet. The second thing, the electricity cost in Somalia, it's very, very high, starting from 0.5 up to $1 per kilowatt hour. It depends on how far you are from the city, especially from Mogadishu. So when it started from Mogadishu is 0.5, and every time you go farther than Mogadishu, the price increase and reach up to $1. Some places it's up to $1.5. That's why it's a little bit difficult for the rural and pre-urban areas to have access to electricity. It's not interesting for the private companies to reach that area, since they don't have any TOIR. They will think about, okay, if we reach 100 kilometer or 200 kilometer area, are we going to get our investment back? Can they pay? And in most of the cases in this area, they cannot pay. They cannot afford $1.5 electricity. So it's not something that's very interesting for the private companies. So these areas, the small villages and the rural areas and the urban areas, they rely more on the charcoal and firewood. And that's actually caused a huge environmental issue, especially here in Somalia, since we have a very difficult and now we face a very difficulties with environment, since we didn't see rain in 2 years, then rain will come very heavily. That will cause a lot of problems. So this kind of fluctuation in the weather. And lastly, the existing mini grids in the rural and pre-urban areas were established by 90% of them were established by NGOs that they contract and foreign countries that they will come to the country, they will install the solar and they will just leave. So there is no operation and maintenance services that comes after it, and that causes a lot of problems because solar, if you cannot maintain it, if you're not maintaining the system, it will stop with the time, because the users can increase, the village can have more businesses, they will increase their incomes, they will increase everything, so they will need more solar in the future, and there is no one to maintain it. The system will end up dying, or they will end up taking the system parts to parts, and everyone will take some of it and they will just move on from there. So that's one of the issues we are facing. But thank God, since 2020 and up to 2025, the numbers of solar energy companies in Somalia has increased. Very good quality companies, and the trust, it's a little bit was built since 2022 with between the NGOs and the private companies, that there is private companies in Somalia who can do these installations and they can give a good quality and they can maintain the systems. Next slide, please. So since there is no national grid, we are focusing more on in establishing mini grids in different areas. That could be challenges sometimes, and that brings some problems sometimes. So because between the area and the other area, or between the village and the other village, there is a small houses that goes between them that we cannot reach. But for the last 2 years, I've been thinking of solution of connecting the mini grids with small standalone systems, solar systems for the houses. That's one of the solutions that we are working on, and that's one of the benefits. Second thing is the cost reduction. Since we are using solar and battery storage, we reduce the electricity cost up to 30 cents from $1.5 and $1 up to 30 cents. And that becomes cheaper, and that increases the number of connections with the time, increase the economy of the village, increase the usage of the energy itself. Third thing, we reduce the environment issues because of charcoal and the diesel generator and things like this. And lastly, we go into a large scale of distribution. Once we start with one village, we find the need in the other village, after it, then the other village, and the other village, and things goes on this way. Next slide, please. So the benefits from the solution that we are providing as a private companies, especially in the urban and the pre-urban villages, that we find the electricity supplier, if they have one at that time, and we try to create a partnership with him, and replace his generator with, not a fully replaced, but we will be using his generator as a backup. We will supply him with the solar system like batteries, solar, then his system will be hybrid. And that will be reducing how many hours that he used the diesel generator, and that will improve the reliability of the system and the quality of it. Second thing, when it comes to the customer side, they will have a more affordable electricity. They will have access to the electricity, more access. The service will improve since there is an O&M and they understand more about the solar, and there is a company there who can help them to understand more about the solar, so the service increase, and we will be part of improving the climate change that's going on. Next slide. So the key challenges that we face always as a private company, that as I mentioned earlier, there is no national grid that's managed by the government and can be later combined with any mini grid that was established by the private company. Everything is private here, so there is no national grid. First thing. Second thing, there's a very lack of finance and investment for the private sector. Most of, like 90% of the investment that comes to the country either goes through different kind of NGOs, it either go to the banks, through banks, and banks themselves are private. So the finance rate, it's very, very, very high. And whereas there is a donor who's ready to pay, there will be always trust issue. As Somalia, we are just improving and we are just coming out, as we had a lot of the war was going on. We didn't have this flexibility and the capacity to reach to the other world, but we are improving now. There's a little bit there's small donors who's ready to take the risk and come to Somalia, and they always like the work that we do, and they come back always, and we get a lot of recommendations. So this is one of the, and we got like for 2024 we received an international international investment. So we are one of the companies, the only companies in Somalia who received international investment to establish especially mini grids only. The third challenge is the technical capacity. Since we are just exploring the solar energy and the renewable energy as an overall, we didn't have the knowledge for it. So creating this technical capacity and training the local technicians, and especially when it comes to the mini grids that's outside of the city, you need to collect some employees from the same village, then you need to train them to give them basic training about the solar energy. So this is one of the challenges. Last thing is the quality. Because I think when we go to the market and we ask, especially China, when we go to the market and I said I need things to be shipped to Somalia, they will ask you which quality do you want, A, B, C. It depends on the quality because there is no quality control once anything's that coming into the country. There is no quality control for it. And the concept of the Somali that they always like to go to the cheapest price instead of the quality. So this is one of the challenges that we always face. Next slide. So lastly, the way forward, we are working, as I explained earlier, we have almost another 20 mini grids we are trying to establish, and that will improve the environment of the country. Second thing, the social, more people will have access to electricity. Lastly, the finance, they will have cheaper electricity. First thing. The second thing, their economy will increase by having access to electricity. They will have more job opportunities. So this is what we're working on now as Tamarso. Next. Yeah, that's it. Thank you so much.
Thank you very much, Jawahir, for the very interesting presentation. Yeah, definitely facing many issues in terms of energy there in Somalia, but in that regard, Tamarso is doing an incredible job. So thanks for showcasing this presentation with us. It's very, very appreciated. Ladies and gentlemen, that was the last presentation of the day. And now we will move to the audience Q&A session. So Maya invites all the speakers to turn on your cameras so that we can begin with the Q&A session. And dear audience, this is your very last chance to ask your questions in the chat. So I would invite you to do it. Let me say that we have received many questions from the audience. Thank you very much for that. We'll try to cover as many as possible, and I will try to follow the same order, but not necessarily. I'm looking to my left because it's where my screen is. So the first question goes to Charlotte, and it says, what measure do Electriciens Sans Frontières ensure that the system installed are sustainably managed post-crisis period to ensure that the countries supported are empowered post-crisis? Thank you.
Thank you for the question. So actually, we are maintaining, we are having a distance control of the installations from France, because we are based in France, through monitoring. Thanks to the monitoring, we can check how the installation is working from far away. And also we have local partners, so associations and the beneficiaries of the installations with who we can be in contact in order to resolve the problems. And moreover, we have in our project dimension of trainings. And we try to train as much as beneficiary as possible for them to be able to resolve any problem or technical problem of the installation that can be resolved by a non-technical person.
Thanks, Charlotte. I think it's very well answered. Thanks a lot for that. Now we'll ask a question for Florian. And it says, what percentage of wind exploitation has EnerKite energy systems established in the African continent? And also, what is the success rate on the continent as well?
So far, we have no projects, and we have not very an outreach to the African continent because at this moment we are working on the first system to be certified in Germany. So most of our power goes at this moment in this direction because we are a small company. But I really look forward to explore opportunities in Africa, because for me that is the main beneficiary of this kind of systems. maybe Ukraine also for the decentralized part of energy supply. But yeah, I would like to explore Africa more and know better the market there, and also the challenges that are obviously there for our kind of system to implement it. No? Yeah.
Thanks, Florian. Yeah, we're looking forward to that as well. Another question for you says, what energy capacity can EnerKite deliver in a standard module?
Yeah, so the first generation will have a capacity of 100 kilowatt, and will be able to deliver 500 megawatt hours, depending on the local conditions per year. So in Germany, we say it's around about 150 households. Of course, in Africa, other regions, it could be more, no? Like 200 to 300 households that could be catered by this kind of system. No? So small and rural communities, maybe with a production facility nearby also, no? Or farming, could be a very good showcase for this kind of system.
Thank you very much, Florian. We will answer it. Now I will direct a question for Rahul about the grips. It says, are there post-project development phase sustainability plans for projects managed by grips to ensure scaling of the installed solutions?
I think, yes, we are working on it, especially with recycling of solar panels and also batteries. So every 8 years we have battery replacements. So we do consider recycling, we do factor in recycling into our cost. And we do have tied up with some suppliers and R&D firms in Europe who's into recycling. But we're still figuring out how to move them. I mean, it's not cost efficient to move them from Africa to Europe, but we are working with them to bring them towards Africa, closer to these countries, to work on these efforts.
Thank you, Rahul. Now a question regarding the in-wave technologies. This is for you, Jeff. The question says, if cables are floating, does that create problems for local fishing vessels and other small sea traffic? This would be very interesting to look at for the East African coast, which has damped net wave action due to coral reefs. What would it require to do a pilot project in East Africa and Kenya in particular?
Thank you for the question. We have done quite a lot of feasibility study all over the world, because this is very much site-specific project. One obvious thing is we have to avoid environmental impact, especially marine protection area, MPA. So we always do the study apart from that space. Other than that, obviously the fishery villages, we provide information to be protected this device. So it's not really heavy traffic area. We cannot, obviously, because of the mooring system. So I didn't explain much about the technology itself. It's a buoy, the big floating buoy on the water, simply connected to the rope. That rope is actually to be protected as a clear warning notice to be fenced. But other than that, it is actually much less space we require compared with other solution, and capacity factor is more than 35%. So in terms of the efficiency, we are quite significantly high. So sorry about that. So in conclusion, it is always site specific. Generally speaking, we are very good solution in terms of the much less space. It's very much expensive land price. We don't need any, and we don't need any subsea cabling. So that is the benefit. Okay, thank you so much.
Carlos, we don't hear you.
Thanks, Okan. I was speaking on mute. Thanks, Jeff, for the answer. That's really well answered, I think. Now moving to JLA Hydro. I was saying that you, Richard, we have received a few questions about the kits. One says that the turbine kits could be very interesting to do in Kenya. And the question says that will GLA Hydro guarantee performance of these turbines and provide maintenance support? Thank you.
Yes, we can provide some support, but the idea is for the owner and operator to organize the maintenance by himself. As I mentioned, so the buyer will be assembling the turbine by himself, so he will know it by heart and he will know exactly what to do to maintain it. We provide all the information for the maintenance, and if there are any questions, we will be available, of course, but the buyer would have, or the operator would have to organize the maintenance.
Thank you. Another question for you, Richard. Do you have only up to 20 kilowatts or even the higher capacity, such as 1 megawatt or 5 megawatt?
No, so the kit, the turbine that you built yourself, it's up to 20 kilowatt. But we can supply turbines which have a bigger capacity, of course. But those, we would be manufacturing them ourselves. We would be coming on site to install them, to commission them. But the kit is 20 kilowatt. But otherwise, yes, we can supply solutions for bigger installations as well.
Thank you, Richard. Now, time for Tamarso, Jawahir. We have received a question that says, well, I presume the mini grids are solar powered. What is the cost of power delivered? How is the supply demand gap managed? For example, solar only available in the middle of the day, but demand more likely to be morning and evening. Also, if there are mini grids used for domestic use only, or also for commercial operators. Thank you.
So regarding the cost, it depends on the area and the size. Second thing, the solar, it depends on, it's just during the day that we use, that's why we use batteries as a backup. And then we have another backup that's its generator, but that will be used like for 2 hours, 3 hours during the 24 hours. This second thing. Third thing, it can be used for even commercial, and once we supply for the town or the village, all the shops or any other businesses that's there will be connected to this mini grid, and they will be charged same as the household usage.
Thanks a lot, Jawahir. Okay, now I will try to make some more questions before the end of the webinar. For example, there are a few questions for EnerKite. Florian, someone asks, what is the weight and volume of the EnerKite systems? And also, how do you ensure security, considering vandalism of the equipment? Thank you.
Mm-hmm. So the volume of the system, when it's transported, is 3 20-foot containers. And then the system is assembled on site. The weight, the total weight of the system is around about 20 tons. The kite itself weighs 150 kilograms, so it's very lightweight. It's like a styrofoam plate from the density, so it's very lightweight compared to the area. And the safety concerns. So we have a safety zone of 50 meters radius around the system where the system should be fenced. So that is the area that should not be accessible, because also we have a emergency descent function, and that is the area where there is some danger if there is an emergency descent. So yeah, so the system can be placed around 120 meters from the customer.
Thank you, Florian. Thanks a lot. Another one for grips says, is the lease a fixed monthly payment or based on energy delivered?
We have both the models. The customer in Zambia is lease, which is fixed monthly payments, but we also do PPA agreements based on the country and the regulations. So we operate all throughout Sub-Saharan Africa, so east, south, and west. So again, depends on the country, but we offer both.
Thank you. Another one for you. Does RIP cover all maintenance and replacement of hardware over the life of the contract? How long is the contract?
Again, it depends on the business investment model and the requirements of the client. But we usually do contracts which are 10, 15, or 20 years. And yes, throughout the whole period of the lease or the PPA, the operations and maintenance of the plant is fully covered by GRIPS.
Thank you. For Jeff, regarding the INGINE technology, what would be the cost per kilowatt? Because you compare it with, for example, the digital solutions that tend to be expensive, but how cost effective it is compared, for example, with solar technologies.
Thank you for the question. Normally speaking, this is a next generation technology. Normally, ocean energy technologies are quite high in terms of the LCOE because they're aiming utility scale project in the first place. But we are very much modularized, the small scale, and we are talking about just approximately 20 cents per kilowatt hour, which is still competitive compared with the diesel generator in the remote islands, because the remote island, because of the distance, the diesel generator is more than 20 cents. So we are comfortably say to compete against the diesel gen. I think because this is a very much development stage, demonstration stage. Once we successfully deploy this project, our price will be going down much lower significantly once we achieve only 1 megawatt capacity. So which is very important stage at the moment. We will share more information by email if you like. Thank you.
Thanks a lot, Jeff. Now I think this will be the last question of the session, being mindful of the time. It's again for you, Richard. It says that the hydro sites are very specific. Does GLA provide the design input for individual sites? Thank you.
Come again with the question?
It says that the hydro sites are very specific. So does JLA provide the design inputs for individual sites?
So again, for the GLA kit, it's a standard turbine. So we will have to adapt, or how to say that. So based on the site specification, we would be able to exploit some of the capacity. We might not be able to exploit all of it. But again, that's a standard product which is aimed to be accessible and affordable for low-income projects. But for other projects, yes, of course, we do help with all the design and conception support. Yes.
Thank you very much. Well, dear audience, this is the end of the webinar of today. Thank you very much for your attention. From Mayor E side, I would like to extend our thanks to all the speakers that are today with us. Thank you very much for your presentations, for your efforts, and for your contribution to this campaign on the topic renewable energy generation technologies. It's been super interesting to know about your technologies and projects, and we are looking forward to continue partnering with you. Also to the audience, thank you very much for your patient hearing and also for all the questions. There are many questions that couldn't be answered today, but no problem. We will share a report with the speakers, including your contact information and the questions that you have for them, so they can get back to you after the webinar. But yeah, we have a lot of questions and a lot of people interested in contacting the speakers. Finally, also, I would like to extend My thanks to my organizing team of I4E, all the colleagues like Okan and Jens for the support. And with that, I will go to the last slide of the day. Oh, that's closing remarks. For inviting you to the next webinar of the I4E series that will take place 4th of September 2025. And the topic will be energy storage and circularity. So thank you very much, all of you, and hoping to see you in September for the next edition. So thank you and have a good day.
Thank you very much. Have a good time. Bye-bye. Thank you.
Thank you, Florian.
Bye.
Thank you, Carlos. Bye.
Thank you. Thank you for your participation.